Hello guys, welcome to my channel. So today I'm back here with one more video, and this video is again for a very important interview question, and this interview question is going to be for concurrency, and this is not specifically for any skill level or any experience level person. It can be asked to any person, but I have seen that this question being asked to only senior developer or the lead developer, right? So this is a very important question for them. So before we move on to what future is and what completable future is and what is the difference between them, if you are new to my channel, if you haven't subscribed to my channel yet, please do. Now let's see what we have here. So the link for this page you can see here also, but I will mention this on the video description also. So that is that. Now let's move on. Alright, now let's jump on to what is future. So future is an interface in Java, which is not a new feature. It is already there and introduced in Java 5, right? So future was specifically used for asynchronous task, right? Now let's first understand what is asynchronous task and what is synchronous task. So here let's take an example. So let's say that I have two tasks, task 1 and task 2, but the problem is that task 2 has to be worked on only when the task 1 is completed. Now here comes an order, like first task 1 has to complete, then only task 2 can complete, right? But there can be more tasks like task 3, task 4, which are not dependent on these two. Their order doesn't matter. So with synchronous task, what was happening is, like, let's say we have a web application. So usually task 2 has to wait for task 1, and while the application is waiting, the application isn't doing anything. It is sitting idle, wasting resource, and the user experience is also not good. Why? Because the user is seeing a wait period. Maybe he is seeing a loading circle showing that something is happening at backend, but this is not a good user experience, because of which we thought that maybe synchronous tasks are not good. So let's switch to asynchronous task. Now what are asynchronous tasks? Let's take the same example. Let's say we have 4 tasks, task 1, task 2, task 3, task 4, and there is a dependency between task 1 and task 2 that task 1 has to be completed before task 2. But while task 2 is waiting for task 1 to be completed, task 3 and task 4 can actually be operated on. So that is what asynchronous design was saying. Like, our application doesn't have to wait, it can continue working on other tasks which are not dependent on this task, right? So this gives us some kind of leverage that if we are waiting for something to happen, let's switch to other task. And that is why future came into appearance, because it was providing us a feature where we can create asynchronous design, right? This is what is future, right? Now we have understood it theoretically. Now let's understand the code. So here I have a sample code. It is written there, but I will choose, or I will prefer it to show you by writing it down entirely and explain it line by line, right? And then we will move down to drawbacks. Alright, so this is my dummy class. It doesn't have anything, just a main empty method, right? So now here we will see like how we can actually create an asynchronous task. So for that, like I said, we have a future interface, right? So if I were to go here, so you can see that this is an interface of a generic type. It can contain any type here, right? If you guys are familiar with generics, then you know what this means. And we are not going to go deep into this because this is not why we are covering this video. So this interface has four main functionality, which are cancel, is cancelled, is done, and get. And this get method is overloaded, and then we have this get method also. So basically we have 5 methods, but of 4 different types. So quickly let's understand each one. So what does get method do? So get method basically says that, let's say you are working on an asynchronous task. So when we say asynchronous task, that means that it may have to wait for a certain duration of time for the result to get back to us, right? So this get method is getting a result after some kind of computation, right? So this get method is actually giving out something that we have operated on, but the catch is that it may not ready yet. So if it is not ready yet, that means that it has to wait, and that is why we have this interrupted exception, which basically says that right now if we are waiting for something and something happens bad and other thread interrupts this one, then this exception will be thrown, right? So we don't have to go deep into what exception are they throwing. Point is that it is waiting. So you can see this method as wait method. I'm not saying it is same, but it is actually waiting for it, right? But the point is this get method is overloaded also. So here I can also mention the time. This time can be the duration. Till then you want to wait for the result to happen. If the result doesn't happen within that duration of time, then you can interrupt it. That means that if you haven't got anything, then either you can cancel the operation or the asynchronous task, or maybe do something else, whatever you want to do, right? So here you can have that functionality, and this time unit is like if you want seconds, minutes, milliseconds, sorry. So whatever unit you have, that you can mention here. So these two methods are similar, in which scenario that you can see that this get method basically wait if necessary, right? Here it is mentioned that it will wait if necessary for at most the time given for the computation to complete, and then retrieves the result if available, right? So that is what this get method do. It is just to obtain the result, and same goes for this method also. Now let's come back up a bit, and then there is this cancel method. Like I was saying, let's say for a particular duration of time, if our result doesn't come back, then we can cancel it using this cancel method. Here we have to provide true or false, which means that do you want to cancel, right? So if you want to cancel, then you can just do true here, otherwise false, right? So that is what this method do. It just cancel your asynchronous task. And if you want to verify if your asynchronous task has been cancelled, then you can use this boolean method, right? Now when we actually have to get the result, we can also check if our asynchronous computation has been completed or not. To do that, we have method is done. So this basically tells us if the execution is completed, then get the result. Otherwise you may have to wait for who knows what duration, right? So these were the methods in our future interface. Now let's see the working example. So we know that this is an interface and it can be of type anything basically, right? And let's say future object. Now how do we create an asynchronous task? So first I need a thread. So I will choose executors API here, and I won't do anything. I will just create a single thread. So new single thread executor, and we will just do submit. And this submit method is for either runnable task or callable task, and we know that callable returns a result, which is your future, right? Future task basically. So here I would use Lambda Expressions Java 8 basically to execute something, right? So here let's do something. So what I want to do is I want to wait for 2 seconds, and then I will print, let's say, hello world. So I will use time unit, then I will choose the time unit, and then I will sleep for 2 seconds, and here I will just return hello world. Alright, good enough. So what this will do is this is not doing anything. It is not actually operating here. It is just giving me an object after waiting for 2 seconds, which means that if I immediately try to get the output using our get method, we won't get anything immediately because we have to wait for it, right? And again, like we have already seen that get method throws execution exception and interrupted exception. So if I run this code, let's run it, then it won't do anything immediately. It will wait for a certain duration of time. But let's say if I want to check also, if I want to print out something till actually it is waiting for this to happen, right? So I can use another method of future interface, which is future object dot is done. So if it is not done, then just tell me that still waiting. Otherwise I will return the result like this. So now let's run this. So as you can see here, till 2 seconds we saw these many still waiting, and then eventually we got a result. So this was not immediate, right? This get method will wait till we actually get the actual result, and that is why we have this is done method. Similarly, we can try to cancel this also, and if we can, then we can also do something after we are canceling our task, right? So you can then try to do something with this code, because this was just a demo, it was not the full-fledged code. But here you can see that how we can actually create an asynchronous task and check the functionality of some methods of our future interface. Now this was all about future. Now what was the drawback here? Why did we had CompletableFuture in Java 8, right? That is the big question. Now what is the problem here? Because I don't see any problem here, but let me tell you about few problems. So as I have mentioned here, that future cannot be finished explicitly. Like we can cancel the future, but we cannot complete it. If I know that this asynchronous task will return this, then even then I won't be able to complete it, which is not a good benefit, right? And then without blocking, we cannot do anything else with the future result, right? Because we have to wait. Then there is no way to execute multiple futures simultaneously and then combine the result. Let's say that this hello and this word are being fetched from two different futures, and then I want to combine both of them and then produce hello word, which cannot happen with future. This is again a big headache, right? And the major concern is that there is no exception handling. When this happens, that I won't be able to know, right? I will lose a lot of things because there is no exception handling construct in the future. This is also a major drawback. So CompletableFuture again is a class which implements your future interface. So this interface is being implemented by CompletableFuture, which means that whatever features you had with future interface, that is by default coming with CompletableFuture, right? Then we had more functionality. So if I say like there are exactly 59 methods in our CompletableFuture class. You can also check the official Oracle documentation. There you can see all the methods. We are not going to cover all of them, but as you can see that these were the drawbacks because of which CompletableFuture came into the appearance in Java 8, and this is why it is majorly being used right now, because this achieves asynchronous task not perfectly but more than enough, right? So this was a major feature, and this was the main difference. These four are the big difference when you compare future with CompletableFuture. So I think we have already answered like what is the difference between future and CompletableFuture, but we should see some live example or code examples of CompletableFuture also, right? So you can read all about this here, but as I have already said that CompletableFuture is a major improvement over future. So now let's see the working functionality. So like I was saying that we cannot implement multiple futures simultaneously and then combine the result. I will show you this example using CompletableFuture also, right? But first the example that we did here, let's try that whatever features we had with future, how can we implement this with CompletableFuture? Alright, now we have again an empty class with empty main method. So like I was saying, that first we should see CompletableFuture example like we just saw for future, right? So let's see how we can implement the same. So first we will create an object, and this is a class, so we can create an object easily. So we will do, let's say, CompletableFuture. Yeah, that's okay. And then new CompletableFuture. So this is how we can simply create an object. Now let's create a thread again using executors API, and again new single thread, and let's submit this one more time, and using Lambda expression again. Right, now I just had to print hello world, that's it, right? So again I will wait for 2 seconds, and then what I have to do is I can return hello world, or there is one more functionality which I wanted to show you, which is that we can complete our asynchronous task using complete method, and we can directly do hello world. This way we don't have to actually wait for something to happen, we can complete it also, right? So this is a really big feature which we did not had with future interface. Now let's have try catch here. Alright, so good enough for now. Now again I will wait for the output or the result to get retrieved. So I will again check if we have got the output or not yet. Till then I will just do still waiting, and then I will print the output. Now let's again throw some exception. Alright, good enough. Right, so now let's try to run this also. So you can see that again this is same output that we have seen with our future interface. So you can see that with CompletableFuture also we can do this similar thing that we were doing with future interface, right? And we had a lot of added advantages. Now let's see the major advantage that we had, which was chaining, method chaining, or you can say if we get the result from one future, then we can combine it with the other to get the actual outcome, which is a really good feature, right? So now let's see that example. Alright, so here I will show you 2 ways to achieve this. So what we have to do is we just have to print hello world, that's all. And I will show you 2 ways to do it. So first let's do the simple way, which is that we can create a CompletableFuture object. So again this has to be string because we are returning hello world, which is a string, right? So let's create CompletableFuture 1, and here what we will do is we will do CompletableFuture dot, now we have a method supply async, right? So let's see what this method is. So this supply async method returns a new CompletableFuture that is asynchronously completed by a task running in your common pool with the value obtained by calling the given supplier. So basically it is just giving you your completed asynchronous task, and it will return you a new CompletableFuture object. That's it, and that is what we want, right? So what I want is I want to print hello world, but I will break it down into 2 parts. What I will do is I will create 2 separate asynchronous tasks where one will return hello and the another one is actually going to append this hello with word to produce the actual output, which is hello world. So this is my agenda, and I know this is not an ideal example, but this will get you enough to get started with more complex things, right? So here what I will do is, it receives a supplier, so I will just do that return hello, right? And then I will use a method then apply, which is just for applying something to this output, whatever this is returning. So this is what we was saying before, that this is method chaining or combining the outcomes of multiple completable futures, right? Then compose, then apply, these are the methods to do it. So right now let's see the example of then apply, then we will see the example of then compose also. So here what we have to do is, we are getting the data hello, let's say hello, which is actually hello which we are getting. So what we have to do is, we have to add word to this hello, and that's it. This is what we had to do. After getting this, what I can simply do is, so here I will just do CompletableFuture dot get and throw the exceptions, and that is all. So now let's try to run this. So here we are not waiting for anything to happen, so it will happen immediately. So here you can see that we got the output, which is good enough, right? Now let's see the second example. So here what I will do is, I will create two static methods. So let me first write them down, then I will explain also what we are doing. So this is going to return string, and this one is to return hello. So ultimately what we are doing here is, we were returning hello, but here I will return separate CompletableFuture objects, right? And this one will return a separate instance or an object, and this one will do the similar thing that we did before, that it will return hello, right? And similarly we will have another method which will do this hello world and return hello world. So here let's say get hello world, and here we will have a data which is your hello message. So let's say hello message, and then here what we will do is, we will do word here, and hello message is going to get appended or inserted before word, right? So this is what we are doing here also, and the similar way is doing these two different instances. Now how do we combine them? So again we can use then apply, but what will happen is, let's first do this. Let's add then apply here also. So the type is going to be string again, and CompletableFuture 2. So here what we will do is, we will just say method name, which is our get hello dot then apply, and here we have to provide the data, which is hello message, or hello we can say, that we did before also. And here we will provide this output to our method get hello word as an input, right? So here let's say hello. So see here what is happening is, this won't return us CompletableFuture of type string. What it will return us is a CompletableFuture of type CompletableFuture string, which is not what we want. That is why we need here something else. That is why we need then compose, because then compose actually flattens your output also. So here we want CompletableFuture, and that is why we will use then compose here. So here we have also answered another interview question, which is what is the difference between then apply and then compose. So then apply is specifically used if you have a synchronous mapping function, right? And then compose is basically used for your asynchronous mapping function, and it will return a future with the result directly rather than our nested completable future object, right? Which is helpful in this scenario. So now if I similarly do the same thing for CompletableFuture 2, so it will print me the same thing, and it should be done immediately also. So as you can see here, we got 2 hello world, and which is what we wanted. So this is what I wanted to show, and here we have covered 2 important interview questions, which is what is the difference between future and CompletableFuture, and then what is the difference between then apply and then compose. And then there are more interview questions, but this is how you can start working on a concept and then keep growing. So this was the agenda for me to make this video, and I really hope that you might have learned something new. If you did, do not forget to like, share and subscribe to my channel. And if you have any idea, any concept idea in your mind that you want to learn that maybe I can teach you, then please let me know in the comment section. I will try as quickly as I can to make a video on that also. So this is it for this video. I really hope that we will meet in some another video. Till then, have a good day, stay safe, and bye bye.